Hey guys, Miss Miklos here with another exciting lecture. Today we're talking about piecewise functions, and just a heads up that for most of you, this is probably the most difficult topic that we are discussing this chapter. In a lot of ways, it's probably the only new thing we're discussing this chapter, so I would make sure to really pay attention to this particular lecture. In fact, I'm splitting this lecture into two parts just to make the videos kind of smaller. The first one, we're going to talk about piecewise functions in general, and the second lecture, we are specifically going to talk about what we call greatest integer functions. So that's why you guys will see two different parts to this particular lecture. So I want to start by just reminding us what is a function. And we know that a function means that for each input, there is exactly one output. Today, we're going to be talking about what we call a piecewise function. And just like it sounds like, a piecewise function has different pieces to it. Our official definition of a piecewise function is a combination of equations, each corresponding to a part of the domain. We know domain means our x values, so that's why this is still a function, because each x value is still going to only have one y value. So we're really going to be doing three different things with piecewise functions today. First, we're going to be evaluating using piecewise functions. Secondly, we're going to be graphing the equations of piecewise functions. And lastly, we are going to go ahead and look at a graph of a piecewise function and write the equation of it. So our first example here says evaluate. F of x equals x plus 2 if x is less than 2. F of x equals 2x plus 1 if x is greater than or equal to 2. So the first thing I want to point out here is our domain. Okay, so that's telling us the different x values that we're going to be working with. I'm also going to be labeling these number 1 and number 2 just to make it kind of easy for us to talk about. So when I look at this first example, f of 0, okay, we need to determine which domain does 0 fit into. Is 0 less than 2? Or is 0 greater than or equal to 2? We know 0 is less than 2, so I'm going to substitute into this top equation only. It means that I could care less about this equation. I'm not even going to worry about it. Okay, so I'm just going to write a note that this fits into domain number 1. So I would say 0 plus 2 is equal to 2. And just a reminder, we know 2 really is the y value, and this would give us an ordered pair of 0, 2. 0 coming from our input, 2 being our output. Okay, so our next problem here says f of 2. So once again, I'm starting over with this particular piecewise function, and I need to determine, is 2 less than 2 or is 2 greater than or equal to 2? And we know that 2 is greater than or equal to 2, so it fits our second domain. That means I only care about this equation. I can cross out x plus 2. I could care less about that. So I'm going to substitute into the second equation and say 2 times 2 plus 1, which is 5. And if I wrote this as an ordered pair, it would be 2, 5. Lastly, we're doing f of 4. So if I look at 4, is 4 less than 2 or is 4 greater than or equal to 2? And I know it's greater than or equal to, so I'm going to go ahead and write 2 times 4. I'm going to go ahead and write also that this fit equation number 2. 2 times 4 plus 1, so I get 8 plus 1, which is 9. So that gives us an ordered pair of 4, 9. So the key thing on these problems, I need to determine which domain does it fit into. Because I know I'm only substituting it into one of these because each function, each x value only has one y value. Okay, so let's do another one of these. G of 0. Okay, so first of all, I need to determine, is 0 less than or equal to 3? Or is it greater than 3? We know it's less than or equal to. So I'm using that very first equation. So I would say 3 times 0 plus 2, which is 2. Which is like an ordered pair of 0, 2. Our second one, G of 3. If I'm looking at the domains, I know 3 is less than or equal to 3, so I'm using that top equation again. So I'm going to do 3 times 3 plus 2, which is 11. So I get 3, 11 as my ordered pair. And lastly, G of 6. I know 6 is greater than 3, so I'm going to go ahead and use that bottom equation and do 6 minus 1, which is 5. So that would give me an ordered pair of 6, 5. Okay, so this is what we do whenever we evaluate the particular piecewise functions. Okay, so now we're on to the fun stuff. We're learning how do we graph piecewise functions. And graphing piecewise functions, really all we are doing is graphing two functions, so two lines, on the same exact graph. So the first thing that I'm going to look at is our domain. And I'm actually going to color code this so we can really see everything I'm doing. So if I look at this domain, it says x is less than 1. So that tells me, since we're talking about x's, that means that it's to the left of 1, because values less than 1 are to the left. Our second one says x is greater than or equal to 1, so that is going to be to the right and including 1. Okay, so the reason why it's including is because it has the equal to sign. So that's telling me to the left of 1, this is what I'm graphing. To the right and including 1, this is what I'm going to go ahead and graph. So I'm going to do one specific graph at a time. So let's start by looking at that first line. We know in order to graph any line, we need two things. We need the slope and we need an ordered pair. Okay, now often the ordered pair that we've been using is the y-intercept, but today we're not going to be using the y-intercept. We are going to be using different values, and I'll explain why. But if we look at this first line, we know f of x just means y, so my equation is y equals 1/2 x plus 3/2. So we know our slope is 1/2. Now, I need to find the ordered pair, so what I'm going to do is substitute 1 in. And you guys may be wondering, well, why am I using 1? And the reason why I'm using 1 is because this is where our jump occurs. And what I mean by a jump is it's jumping from this equation to the other equation. These numbers are both 1. If this was 5 and 5, I would substitute 5 in. If it was 0 and 0, I would substitute in 0. So I'm looking to see where does the jump occur at. So I'm going to go ahead and substitute 1 in. Now, some of you might be thinking, well, I can't use 1 here because it says less than 1. And you are correct. And so once we substitute 1 in, I know that that ordered pair is going to be open because it's technically not a solution. So I'm going to do 1/2 times 1 plus 3/2, okay, which gives us a value of 2. So I get an ordered pair of 1, 2, and I know that that is an open circle. So what I'm going to do, I'm going to go ahead and graph 1, 2, and put an open circle. Now, a slope of 1/2, often that means we'd go up 1 and over 2, but we need to remember this is to the left. So instead of going up 1 and to the right 2, I can also go down 1 and to the left 2. Okay, so now I'm going to go ahead and draw that line. Notice that it is a solid line because it says equal. This inequality is reflected in the open circle. So now we're done with line number 1, and we are going to move on to line number 2. So the first thing I need to figure out is what is the slope of line 2, and it is y equals negative x plus 3. So that negative x tells me that the slope is negative 1. And I'm substituting 1 in once again because that's where this jump occurs at. So f of 1, I would say the opposite of 1 plus 3, which actually ends up being 2 again. Okay, this is kind of a weird circumstance that I wanted to take you guys through. So what this means is that we are going to have a closed circle at 1, 2. The reason why it's closed is because we have this equal sign. So I'm going to go ahead and draw in a point at 1, 2. And our slope is negative 1. So I would go down 1 and to the right 1. And draw my line. Now, for the most part, I think students do a really good job drawing to the right. Where we get confused sometimes is drawing to the left. Okay, so we just need to remember, let's double check. This line is rising from left to right, so that means our slope should have been positive, and if we look, it was. Second thing is that I might want to go ahead and use a vertical line test. So if I go straight across, at every single x value, there's only one y value, so this passes the vertical line test. The reason why I would want to do that is to verify that I graphed this correctly. I know every single thing we're dealing with is a function, so if I accidentally graphed both equations going to the same side, that would be a way for me to check that I was wrong. So looking at number 4, we are doing the same thing here. We're going to break it up into 2 different equations. There we go, there's my new pointer. Okay, so I need to look at the domain and figure out what we are doing. So our first domain is to the left and including 0. We know it's including because of this equal sign. We know that our second line is going to be to the right of 0. And because we know all the x values that are greater than 0 are to the right. This time notice, where does our jump occur? And we see zeros here, so that means our jump occurs at 0. So that means when I go ahead and substitute in a point this time, I'm going to substitute in 0. Now our first line here has a slope of 2. So I'm going to write m equals 2. When I substitute in 0, I get 2 times 0 minus 1, which is negative 1, which gives me an ordered pair of 0, negative 1. Just a reminder, this 0 comes from our input, the negative 1 comes from our output. Now I know that this particular line is going to be closed. The reason why it's closed is because it says equal to, and we told ourselves it was including. So at 0, negative 1, I'm going to draw a point. Now I'm going to the left. A slope of 2, normally I would go up 2 to the right one, but I'm going to go down 2 and to the left one. Now quick check, left to right, this is rising, which means our slope should be positive, which is true. So our second line here, our slope, it just has x, so we know our slope is 1. And when I do f of 0, I would get 0 plus 2, which is 2. So I get an ordered pair of 0, 2. I know that this ordered pair is open because of our inequality symbol. So at 0, 2, I'm going to put an open circle. Okay, notice on example 3, these points were at the same point. Here, they're definitely at different points. And our slope is 1, so I need to go up 1 and to the right one. And I'm going to draw my line. Now, just double check from left to right, this is rising, which means I should have a positive slope. The other thing I want to double check is this a function? So when I'm going along here, yes, yes, yes. Right here, you guys might get a little confused, but the answer is yes, because this is not a solution. This is the only solution. So our x value of 0 only has one output, only negative 1. and then I jump up here and it continues, so this is a function. So we're going to do 2 more of these graphing, and for some reason one like number 5 here really tends to confuse people. And some weird things. First of all, I have 3 different equations this time. Also, I just have a number, and we actually saw this on some of the suggested problems back with the first lecture of this chapter. But we just need to remember that g of x just means y. So this first line is really saying y equals 3. Okay, so it's saying y equals 3 for all of these particular x values. Okay, so our first ordered pair would be -4, 3, and it's going to be a closed point. So I'm going to go to -4, 3, and put a closed point. And it's telling me with these inequality symbols that it is continuing until we hit -1, 3. -1, 3 is going to be open. Okay, the reason why it's open is because it is just less than. So these are all the x values that are greater than -4, I should say greater than or equal to -4, and less than -1. They all have an output of 3. Now, we notice our next line here would just be y equals 0. And these ordered pairs would go from an x value of -1, so -1, 0, I'm going to put a solid point, until we hit 2, 0. At 2, 0, I'm putting an open circle. Okay, and I'm going to go ahead and draw this, because these inequalities are telling me that all the values between those 2 ordered pairs are solutions. And lastly, this last set is y equals -2. So my first ordered pair is at 2, -2. So I'm going to have a solid point. And that is going to end at 4, -2. So at 4, -2, I have an open circle, or an open point, and I'm going to draw my horizontal line between those 2. Okay, so in a lot of ways, even though this looks confusing, I think it could be the easiest one, because we didn't have to work a lot to find the slope or ordered pairs of each of those particular parts of our function. Final thing I'm going to do, double check, is this a function? And it is, because here I only have 1 in output. Here I only have 1 output. So that is a function. We graphed it correctly. Okay, and our last example of graphing these, and I want to stress this is definitely a topic. If you're having a tough time on this, please come in and get help from me. Send me an email. I will make you a video, okay? Ask me for help. Our first equation, our domain, is greater than or equal to 2. So that is to the right and including 2. Our second one, x is less than 2, is just to the left of 2. So line number 1. I know my slope this time is 2. Okay, my ordered pair, I'm substituting 2 in. The reason why I'm substituting 2 is because that's where this jump occurs. So I have 2 times 2, which is 4. So that's an ordered pair of 2, 4. I know that this needs to be closed because it tells me it includes 2. So I'm going to go to 2, 1, 2, 3, 4, and put a point. That is closed. My slope is 2. So that means I'm going to go up 2 and to the right 1, which means I'm going off the graph here, and I'm going to draw that line. Okay, and I'm doing that because we said this should be going to the right. From left to right, this is rising, which matches my slope of 2. Okay, line number 2, our slope this time is -1. And when I substitute in 2, I get the opposite of 2 plus 3, which is 1, which gives us an ordered pair of 2, 1. This is going to be open because of my inequality symbol. Now a slope of -1 tells me that I normally am going up, I'm going down 1 to the right 1, But this time, since I have to go to the left, I'm going up 1 to the left 1. Okay, and once again, when I'm double checking, I don't want to check out this arrow. I want to see, is this rising or falling from left to right? And if we look, this is falling from left to right, which means that our slope is negative. If I go ahead and do my vertical line test on this, we would indeed see this is a function. And our last two examples for this section of the lecture, if we look at this, we need to write the equation for each function. Okay, so I'm going to start by just writing f of x equals, and then our little fun bracket symbol there. And I'm going to go through, and I really need to break this into two different parts. Okay, so I'm going to circle the parts in different colors here so we can really examine these. Now my first one I've done in red, and if we look at that domain, it looks like x is less than 0. Now where I got that from, it is to the left of 0. Okay, so everything to the left of 0 is on this first equation, this first graph in red. The second graph here is everything to the right and including 0, and the reason including is because it is a solid point. So I'm going to say for our second one, x is greater than or equal to 0. So now we need to think, in order to write the equation for each function, this is really similar to what we did in a previous lecture when we wrote equations of lines. So when I'm examining this is in slope-intercept form because I know this is y. So we could either use point-slope form if that's applicable, or if it's easy for us to see where the line crosses the y-axis, I think it's easy to use slope-intercept form. So if I look at this first line, it definitely looks like it crosses the y-axis at 2. So I know I'm going to have something plus 2. So I really need to examine this slope. What's happening from left to right? And if I'm looking at it, it looks like it's going up 1 and to the right 1. Up 1 to the right 1. So that would be a slope of 1. So I'm going to write x plus 2 because it's like 1x. Now my second line, it looks like the y-intercept here is at 0, so I'm not going to write anything because I know I don't need to write 0. And to determine my slope, once again, it looks like it's going up 1 to the right 1, up 1 to the right 1, so I am just going to write x. So this right here would be our answer. Okay, this is the equation of this particular piecewise function. Okay, so let's go through one more of these. F of x equals whatever our equation of the piecewise function is. And once again, I notice there are definitely two pieces to this graph. I think this one is a little bit more difficult because we can see our jump here occurs at -1. So this first part is to the left and including -1. So I'm going to write that as x is less than or equal to -1. Our other portion is to the right of -1, so I'm going to write x is greater than -1. Now we said in order to go ahead and figure out these points, or really I should say the equation, we need the slope and we need to figure out what the y-intercept is. Now this one's more difficult because I don't see clear points on the y-axis for us to just write down. Now sometimes, like if I look at this equation, even though it didn't continue this way, if I had drawn that line, okay, it looks like our slope is up 1 over 1, up 1 over 1. So if I went up 1 and over 1, it would continue and I could kind of see where it crosses. Okay, that could be very helpful. In this particular case, it looks like it crosses at 2 and our slope was 1, so I'm going to write x plus 2 when x is less than or equal to -1. The other way that I could have gone about doing that, I could have used point slope form, like we learned in a previous lesson, and substituted in one of the ordered pairs. It doesn't matter which one. I might choose this one right here, which would be at -2, 0. So I would say, okay, well, y minus 0 equals our slope, which is 1, times x minus -2 or plus 2. So y equals x plus 2. And that is the same exact equation I came up with when I used the slope. Now our second one to me is the most difficult because I can't really tell where that's crossing. It's not crossing at a particular integer. Now the one thing I do notice is my slope looks like it's going down 1 and to the right 2. Down 1 to the right 2. So I definitely know my slope is -1/2 x. I have no clue what the y-intercept is. Is it -1/2? Is it -1/3? I don't know. So this is a case where I have to use point slope form to figure this out. So I'm going to choose an ordered pair that is really easy for me to see, like this one right here, which is at 1, -1. So I would say y plus 1 equals -1/2 times x minus 1. When I distribute, I get y plus 1 equals -1/2 x plus 1/2. And when I subtract 1, I get y equals -1/2 x minus 1/2. So that's telling me our y-intercept is indeed at -1/2. I think this example right here is as difficult as writing equations gets for piecewise functions because we had to go ahead and apply what we've learned in a previous lecture. So this is piecewise functions, just the general overview. In the next lecture, we are specifically going to be learning about greatest integer functions, which is a specific type of piecewise functions. Okay, so I want to give you guys a little extra information, and that is how we can actually graph piecewise functions on our graphing calculator. So we're going to go ahead and redo number 6 that we just graphed by hand, and I'm just going to check my answer by doing this in my graphing calculator. So I'm beginning here by pressing y equals, so that's giving me this menu that we see in front of us. And our first function, it says 2x if x is greater than or equal to 2. So I'm going to put parenthesis 2x parenthesis. So my function is in parentheses. Then I need to put the domain in parentheses. Our domain is when x is greater than or equal to 2. So this is probably the only tough part to remember. To get to our inequality symbols, I'm pressing second, math, and that gives me this menu, and I need to choose greater than or equal to, which is number 4 here. So I'm going to choose option 4 and type 2 and close my parentheses. So this shows our first function. Now I'm going to press plus, there we go, let's try that again, plus, and I'm going to add in parentheses negative x, negative not subtraction, plus 3, and then I'm going to put x is less than 2, so I'm going to press second math and choose option number 5, so less than 2, and close my parenthesis. Now to graph it, I'm going to press zoom 6, and we can see what our graph looks like. Now, the tough thing here is that I definitely cannot tell if we look at these two ordered pairs, what's open, what's closed. If I press trace though, okay, we've talked about trace before. I can use my left and my right arrows, and we can kind of see that it's going to 2 and then it jumps up. And in fact, if I type in the domain of 2 and press enter, it shows me that it belongs on this top part of the function. instead of this part right here. This is the part that matches with the 2x when x is greater than or equal to 2. So this could be a really good way just to double check your work. We definitely don't need to use this, but it could be helpful at times.